Welcome to the lecture on description of function, array, and string. And after the lecture, we will be able to learn the following objectives. Explain functions and recursion function. Define static functions. Understand the arrays and passing arrays to a function. Explain multidimensional arrays. Discuss strings and its operations. Let's start with a brief introduction to array and string. The C programming language is sometimes referred to as a middle-level language. It provides low-level programming capability at the expense of a degree of clarity. Some cynics claim that C combines the flexibility and power of assembly language with the user-friendliness of assembly language. The C programming language provides a data structure called the array, which can store a fixed-size sequential collection of elements of the same type. An array is used to store a collection of data, but it is often more useful to think of an array as a collection of variables of the same type. All arrays consist of contiguous memory locations. The lowest address corresponds to the first element and the highest address to the last element. Let's discuss the concept of functions. Functions break large computing tasks into smaller ones and enable people to build on what others have done, instead of starting over from scratch. Appropriate functions hide details of operation from parts of the program that do not need to know them, thus clarifying the whole and easing the pain of making changes. Functions are fundamental to writing modular code. They provide the basic mechanism for enclosing low-level source code, hiding algorithmic details and presenting instead an interface that describes more intuitively what the code actually does.
Now we're going to discuss functions and declaring functions. Okay, so basically I've actually started the code this time because it's quite a big code, but I'm going to take you through it step by step and actually discuss each point. Now we always start the script like we mentioned in the previous examples, with the include and then Studio H for the header file, so we can actually use functions or commands such as the printf and scanf, which deal with the input and output, their input and output functions. Now we're going to declare new functions. Okay, we're going to mention something new here this time. There's a new data type. It's called void. Now what void is, it basically means that it's returning a value of null. It's not actually returning any value. We use something integer when we're returning a number, a whole number, and char if it's returning a character, float if it's returning a digital with decimal point number. So there's all these different variable types. But for this, we need to declare the same way that we declare a variable, we declare a function. So here we're declaring the function prototypes. The first one is called first, and if it's type void, so it's not going to return any digital integer or character or anything like that. And this one here is called square 5, and that's an integer type. So it's going to return an integer value, and here we've got cube 5, and that's an integer type function as well. In here we've put int main. We didn't need to do that. We can actually remove that just so you don't get confused, but we can put int or any type that we want the main function to return a value. So it's going to be returning a value of integer, or we could just remove that, and then we'll remove this part here saying return 0. Okay, so we start with defining the main function, okay, like we always do. Here we've started up by declaring a variable called num, and we're giving it the value of 0. We don't actually need to give it any value at all, because we can actually start with nothing and then we're going to give it a value later on. It's got a value of null at the moment, so it hasn't even got 0 or anything at all. It's got null. And then now we're going to be calling the first function. Now you can be aware that we haven't actually yet defined the function, but yet we can call the function providing we will actually define it somewhere else in the program. Had this been an interpreter instead of a compiler, it would actually execute line by line or compile line by line. Therefore, when it reaches the first function, it will say, look, it hasn't been defined, and it will just crash. It would start bringing out all these errors messages. But because this is a compiler, it takes the whole code as one, compiles it, and then once it's executable, it executes. So providing it's defined somewhere else in the code, it doesn't matter, even if in a different file. Like we have here, we've got studio.h, which defines the printf and all the other functions that we use for input and output. So first here is called, and that's the first thing that's going to happen. And then we are actually assigning square, so we're calling another function called square5, and we're assigning the value of it in the integer variable called num. Now we're going to be just printing out the results. So it's 5 times 5, and then we put the value num in here, which is basically the square 5. I could have just taken this and placed it there, but I just wanted to give you a little flavor of how you might the different ways that you can actually do the same script. The next line is printf 5 times 5 times 5, which is 5 cube, and we've made a function, and that function basically all it does is multiplies 5 3 times, and that's basically what this function does. So we're calling the function here as well. Now we're going to actually define the function called first. The function called first is of a void, like we said. It's not going to return any value. It's not going to hold any value at all, and all this is going to do is just printf hello from my first function. Okay, that's all it's going to print. It's just that line there.
Defining a function. A function definition contains the actual workings of the function, the declarations and statements of the function algorithm. The function is passed a number of input parameters or arguments and may return a value, as specified by its interface definition. Function arguments are passed by a transaction termed passByValue. This means that the function receives a local copy of each input variable, not the variable itself. Thus, any changes made to the local variable will not affect the value of the variable in the calling function. A function definition in C programming language consists of a function header and a function body. The parts of a function are return type. A function may return a value. The return underscore type is the data type of the value the function returns. Some functions perform the desired operations without returning a value. In this case, the return underscore type is the keyword void. Function name. This is the actual name of the function. The function name and the parameter list together constitute the function signature. Parameters. A parameter is like a placeholder. When a function is invoked, one passes a value to the parameter. This value is referred to as actual parameter or argument. The parameter list refers to the type, order, and number of the parameters of a function. Parameters are optional, that is, a function may contain no parameters. Function body. The function body contains a collection of statements that define what the function does. Function declarations. A function declaration tells the compiler about a function name and how to call the function. The actual body of the function can be defined separately. A function declaration has the parts as shown here. Accessing function. While creating a C function, one gives a definition of what the function has to do. To use a function, one will have to call that function to perform the defined task. When a program calls a function, program control is transferred to the called function. A called function performs defined task, and when its return statement is executed, or when its function ending closed brace is reached, it returns program control back to the main program. Passing arguments. If a function is to use arguments, it must declare variables that accept the values of the arguments. These variables are called the formal parameters of the function. The formal parameters behave like other local variables inside the function and are created upon entry into the function and destroyed upon exit. While calling a function, there are two ways that arguments can be passed to a function. Function call by value, function call by reference. Function call by value. The call by value method of passing arguments to a function copies the actual value of an argument into the formal parameter of the function. In this case, changes made to the parameter inside the function have no effect on the argument. Function call by reference. The call by reference method of passing arguments to a function copies the address of an argument into the formal parameter. Inside the function, the address is used to access the actual argument used in the call. This means that changes made to the parameter affect the passed argument. Function prototype. A function must be declared before it is used. This means that either the function declaration or definition must exist in the source file above the place where it is first called by some other function. A function declaration or prototype is an interface specification. It states the function name, the number, and type of input arguments, and the return value type. It enables the compiler to perform type checking to ensure the argument types being passed to the function match the interface definition, which catches many coding errors at compile time. Some example prototypes are shown here. Recursion function. In computer science, many problems require a divide and conquer strategy. The technique of recursion uses this strategy. In its simplest form, recursion is a function that divides a problem into smaller problems, until the final product can be determined. Computer science was founded on a platform of mathematics and logic. Recursion has been a part of this larger framework for many decades, and it can be found in most computer programming languages today. Recursive functions are very useful to solve many mathematical problems, like to calculate factorial of a number, generating Fibonacci series, etc. Library functions. The standard library has a large number of functions, about 145, which provide many commonly used routines and operations. These functions exist on all standard conforming systems. They are portable and correct, so use them before writing implementations of own. Also, the standard library functions are a good example of quality interface design. Use of short, descriptive function names, intuitive and minimal interfaces. It pays to become familiar with the standard library. Learn what functions are available and their various purposes. Some functions by category are mathematical functions, manipulating characters, manipulating strings, formatted input and output, file input and output, error handling, time and date functions, sort and search, low-level memory operations. Let's now talk about static function. In C, functions are global by default. The static keyword before a function name makes it static. For example, the function fun, brackets, is static. Unlike global functions in C, access to static functions is restricted to the file where they are declared. Therefore, when one wants to restrict access to functions, one makes them static. Another reason for making functions static can be reuse of same function name in other files. Benefits of functions. Novice programmers tend to pack all their code into main brackets, which soon becomes unmanageable. Scalable software design involves breaking a problem into sub-problems, which can be tackled separately. Functions are the key to enabling such a division and separation of concerns. Writing programs as a collection of functions has manifold benefits. Functions allow a program to be split into a set of sub-problems which, in turn, may be further split into smaller sub-problems. This divide and conquer approach means that small parts of the program can be written, tested, and debugged in isolation without interfering with other parts of the program. Functions can wrap up difficult algorithms in a simple and intuitive interface, hiding the implementation details and enabling a higher-level view of the algorithm's purpose and use. Functions avoid code duplication. If a particular segment of code is required in several places, a function provides a tidy means for writing the code only once. This is of considerable benefit if the code segment is latter altered. Now we shall discuss about arrays. An array is a group of variables of a particular type occupying a contiguous region of memory. In C, array elements are numbered from 0, so that an array of size n is indexed from 0 to n minus 1. An array must contain at least one element, and it is an error to define an empty array. Arrays are data structures which hold multiple values of the same data type. Arrays are an example of a structured variable in which there are a number of pieces of data contained in the variable name, and there is an ordered method for extracting individual data items from the whole. Defining array. To declare an array in C, a programmer specifies the type of the elements and the number of elements required by an array. This is called a single-dimensional array. The array size must be an integer constant greater than 0, and type can be any valid C data type. For example, to declare a 10-element array called balance of type double, use the statement as shown. Array initialization. As for any other type of variable, arrays may have local, external, or static scope. Arrays with static extent have their elements initialized to 0 by default, but arrays with local extent are not initialized by default, so their elements have arbitrary values. It is possible to initialize an array explicitly when it is defined by using an initializer list. Processing array. Single operations involving entire arrays are not permitted in C. Thus, if A and B are similar array, example, same data type, same dimensionality, and same size, assignment operations, comparison operations, and so on must be carried out on an element-by-element basis. This is usually accomplished within a loop, where each pass therefore loop is used to process one array element. The number of passes through the loop will therefore equal the number of array elements to be processed. Passing array to a function. In C programming, a single array element or an entire array can be passed to a function. Also, both one-dimensional and multi-dimensional array can be passed to function as argument. Passing multi-dimensional arrays to function. To pass two-dimensional array to a function as an argument, starting address of memory area reserved is passed as in one-dimensional array. Now let's talk about the multi-dimensional arrays. The C programming language allows multi-dimensional arrays. Here's the general form of multi-dimensional array declaration. Two-dimensional arrays. The simplest form of the multi-dimensional array is the two-dimensional array. A two-dimensional array is, in essence, a list of one-dimensional arrays. To declare a two-dimensional integer array of size x, y, one would write something as shown. Now let's explore the strings. The string in C programming language is actually a one-dimensional array of characters, which is terminated by a null character /0. Thus, a null-terminated string contains the characters that comprise the string followed by a null. The declaration and initialization create a string consisting of the word hello. To hold the null character at the end of the array, the size of the character array containing the string is one more than the number of characters in the word hello. Defining strings. Character arrays are special. They have certain initialization properties not shared with other array types because of their relationship with strings. Of course, character arrays can be initialized in the normal way using an initializer list. But they may also be initialized using a string constant as shown. Operations on strings. Language C supports a wide range of functions that manipulate null-terminated strings. strcpy, brackets si, comma s2, copies string s2 into string s1. strcat, brackets s1, comma s2, concatenates string s2 onto the end of string s1. strlen, brackets s1, returns the length of string s1. strcmp, brackets s1, comma s2, returns 0 if s1 and s2 are the same, less than 0 if s1 less than s2, greater than 0 if s1 greater than s2. strchr brackets s1, ch returns a pointer to the first occurrence of character ch in string s1. str brackets s1, s2 returns a pointer to the first occurrence of string s2 in string s1. Char pointer strn cpy brackets char pointer s1, const char pointer s2, size underscore t space n copies at most n characters of the string s2 into the character array s1. The value of s1 is returned. Char pointer strncat brackets char pointer s1, const char pointer s2, size underscore t space n appends at most n characters of the string s2 to the end of character array s1. The first character from s2 overwrites the /0 of s1. The value of s1 is returned. Char pointer strrchr brackets const char pointer s, int c returns a pointer to the last instance of c in s. Returns a null pointer if c is not encountered in the string. Now in the end, let us summarize what we have learned in this lecture. C combines the flexibility and power of assembly language with the user-friendliness of assembly language. The C programming language provides a data structure called the array, which can store a fixed-size sequential collection of elements of the same type. A function definition contains the actual workings of the function, the declarations and statements of the function algorithm. If a function is to use arguments, it must declare variables that accept the values of the arguments. These variables are called the formal parameters of the function. To pass two-dimensional array to a function as an argument, starting address of memory area reserved is passed as in one-dimensional array.